5. Okay, so in this whole chapter, we've been learning to derive, right? Okay, so what are the methods that we know in order to derive?
Product rule, quotient rule, basic rule, and definition of the derivative.
Nice. Okay, so this now is going to be a fourth way to derive. Okay, so calling it the chain rule. So it's just another trick, just like the product rule and the quotient rule, so that we don't have to use that nasty definition of a derivative. Okay, so I'm going to have you write down the definition of the chain rule. Whoa, I went too far. And then I'll explain it to you in, we'll call it nullity terms. All right, so the chain rule is right here. Okay, so write this down in your notes. Okay, and hopefully you kind of recognize the notation. So it starts out as that little circle. Do you guys recognize that little circle? F of. Okay, so it's a function of another function, meaning we have a function that exists inside something else. Okay, so a fog of x, the derivative, is going to be the derivative of the outside. So the g is the stuff that's inside, times the derivative of the inside. Okay. Can I slide over? Everybody got that written down?
Wait, do we need the box station?
Yeah, the part that I circled in red. Yep, that. That's your mathematical. No, there's no plus. There's a times. Mm-hmm. You good? Okay. No? Okay. Good? Okay. So the chain rule in, we'll call it in nullity terms, is when we have a scenario, let's say our function is, we're going to call it stuff to the nth power. Okay, so it's really easy to identify when you would use a chain rule because often you have something that's in parentheses, so some kind of quantity that exists inside something else. Okay, so the derivative is going to kind of be the derivative of the outside. So if I was going to derive my stuff, what would its derivative be? The n. So the n goes into the front, and then the stuff to the n minus 1. That's right. And then all we have to do now is multiply by the derivative of the stuff. So we're going to call this d stuff. Okay, so the derivative of the stuff and then times the derivative of the inside stuff. Howdy. All right, so example 1, you ready? Okay, so let's say our equation is 2 times the quantity of 3x squared plus x to the third power. Okay, so first, tell me what my stuff is.
3x squared plus x.
Good, the stuff in the inside, right? So when I derive this, I'm going to start by deriving the stuff. Okay, so the stuff that's on the outside. So what would the first part be? The derivative of the outside piece. 6. And then times the stuff. Right? Okay, so 2 times the 3, right? 2 times the 3 to get the 6. And then what's my new exponent? 2. And now I have to multiply by the d stuff. So what's the derivative of the stuff on the inside? 6x plus 1. Good. All right, now when it comes to simplifying in chain rule, remember the rule that I say? You never have to FOIL, right? Okay, but you always have to distribute if it's possible. Okay, so you're never going to touch a quantity that has an exponent, ever. The only thing you can do is if it has a negative exponent, you put it into the denominator. Okay, but what we can do is we can multiply the 6 times that quantity there and distribute that through. Okay, so I'm going to distribute that 6 through. So what is 6 times 6x?
Well,
36x. And 6 times 1 is 6. And then we have times the quantity that we're not touching. Okay, and we're going to leave it like that. We will not FOIL. Everybody okay with that? No?
That's pretty easy.
Okay.
How's
Foil and try and simplify.
Okay, let's keep going.
And they're
What?
gonna be like,
Is that
they're gonna be like some sign thing.
You just don't have to. You can if you want to, but why would you do something where you have potential for mistakes? All that's going to happen is it's going to turn into one long equation. It's not any simpler. This is factored form. Factored form is not less simple than standard form. Okay, I think I have another one down here. So I just pulled some off of the textbook. Somewhere, I thought. No, yeah, they're there, okay. Jeez. Okay, so the first one I found that I liked is this one. Okay, so let's do this one. Number 10. Okay, so first, what's my stuff? 4 minus 3x. Okay, so I'm gonna derive the outside. So that's the derivative of the outside. 9 times my stuff. What's my new exponent? 8 times the derivative of your stuff. So what's the derivative of the inside? Negative 3, good. Okay, now what pieces can I multiply? Good. Don't ever touch the stuff that has the exponent. So this is going to be, what's 9 times negative 3? Negative 27 times the stuff to the 8th power.
Can we do a hard one like it's going to be on our homework?
I'm going to get progressively harder. I've got a couple examples. Okay, now this one is written in radical form. Okay, so before I derive this, I'm going to rewrite it in exponential form.
Parentheses to the half.
Okay, so this is equivalent to 3x squared minus 4x plus 6 to the 1/2 power. Okay, so let's go ahead and derive it. So I'm going to derive the outside. What's the derivative?
1/2.
1/2.
Times to
The stuff to the negative 1/2. Good. Okay, times the derivative of the inside. What's the derivative of the inside? 6x minus 4. Good. Okay, so what pieces can I multiply together?
6x minus 1.
Okay, good. So we'll combine those. And then I also noticed that the stuff piece has a negative exponent. So what I'm going to do is in one step, I'm just going to throw it down into the bottom. So I'm going to multiply the 1/2 through the 6x minus 4. So that gives us 3x minus 2. And then we'll throw that other quantity on the bottom. And when I move it, the exponent turns positive. Okay, and I'm going to leave it like that. You could potentially convert it back into radical form, but again, radical form is not any simpler than exponential form, so we'll just leave it there. Good so far? Okay. Let's do a trig one. They always got to throw some trig in. Okay. So for this one, what piece is my stuff? The pi minus 1. Okay, so I'm going to start by deriving the outside piece. So first I'm going to derive cotangent. So who remembers what the derivative of cotangent is?
It's something.
I think no. Negative cosecant squared. There you go. So remember it's negative because it's a c. Cosecant squared. Okay, of our stuff. And now what do I have to do? multiply by the derivative. Okay, so on the inside, see if you can do this mentally. This is a little bit tricky. On the inside, we have pi, which the derivative of pi is 0, because it's just a constant. And then we have 1 over x. So 1 over x in exponential form would be x to the negative first, right? So if I have negative x to the negative first, that's going to be positive x to the negative second. Nice. So we're going to have 1 over x squared. So
Where'd you just get the?
so I just so see this right here. That's the same as negative x to the negative 1, right?
Yeah.
So if you derive that, it's going to be positive x to the negative second. Right? I just put the x in the bottom. So we should probably write this as one fraction. What's the derivative of pi?
Oh, since it's like a
It's a constant number, yeah. So I would probably rewrite this as a single fraction and write it like that. Good there?
fabulous.
All right, this is the hardest scenario you're going to see. I'm actually going to I had this other example, but I don't want to use that one. It's not a bad example. What are we at, number 5? I don't know. So let's say our equation is the square root of 2x squared plus 5 times the quantity of 8 minus 4x cubed. Okay. So how do I do this scenario?
So first take that to the half.
Okay, so rewrite it as a exponential piece.
That's gonna be your stuff.
Okay, what rule do I need to use if I have two quantities that are being multiplied? Yeah, I'm going to have to do the product rule here. Okay, so I'm going to do a first d second plus second d first, but when I go to do my d first, my derivative of my first piece, I'm going to have to use a chain rule in order to derive that piece. Okay? All right, here we go. So we start with the first. What's my first quantity? So I don't touch it, I just rewrite it. So 2x squared plus 5 to the 1/2. D second, what's the derivative of my second term? Negative 12x squared plus my second. Good. D first. So how do I derive my first? Chain rule, right? So we got to do the outside. So what's the first part? 1/2 times my stuff to the what? What's my new exponent? Negative 1/2. Then times the derivative of my inside. So what's the derivative of 2x squared plus 5? 4x.
Wait, so on the second, so do first, do second, plus second be first, and then
Second D first.
in the chain rule?
Well, it required the chain rule on when we did the D second. So when we derived that first, we needed the chain rule in order to derive it. 12x squared is the derivative of your second.
Yeah, but how? Does that make
Yep, because derivative of any constant is 0. All right, now I have to simplify this, okay? And this is probably one of the trickiest parts. You guys are really struggling with the simplification parts, okay? And that's the algebra of this.
I would
Okay.
just multiply.
So on the first term, the only thing that I can do is pull that constant piece in the front, okay? So it's not incredibly necessary for it to be in front, but usually we write any kind of constant piece in front of a quantity. Okay, now on the second term, this is going to require a little bit more
Well, I would first do the
Work.
4x times a half.
good. Okay, so 4x times or 4x times a half is what?
2x.
2x. So what I'm basically going to do is take 2x and distribute it through that first quantity.
I was thinking that actually.
Okay, good. So what's 2x times 8?
2x.
2x times 8
16x.
is 16x. And then what's 2x times negative 4x to the third? Negative 8x to the fourth. Okay. Now I also have that quantity. Do you see my quantity that has the negative 1/2? What am I going to do with the negative 1/2?
You have to put it on the bottom.
It goes into the bottom. Good. So I'm just going to write over 2x squared plus 5 to the 1/2. Okay, and that's as far as you are going to go.
Where did you get 2x?
I got 2x from multiplying the 1/2 times 4x. So multiply that first. Yeah, you try to multiply any constants together first, and then multiply those through any quantity that doesn't have an exponent.
We said that in here on Friday night.
Okay, you guys got this?
Yeah, easy peasy. Until we get to the homework.